Okay, guys, we're going to start a new unit today, and this unit's going to be all about exponents. Now, most people coming into a class like this already have been exposed to exponents, but the first thing I'm going to do is caution you to be kind of careful. For example, if I have an expression like 3x cubed, and then I tell you that x is 2, you should be able to evaluate that expression. But here's the caution. A lot of people will say, well, 3 times 2 is 6, and so I'm going to take 6 cubed. 6 times 6 is 36 times 6, and they'll get the answer 216. Okay? What did I do wrong there? Why isn't that the correct answer? Isaac?
The x is the only thing that's connected to the exponent.
Good point. Only the x is cubed, not the 3. Could you explain that a different way?
According to order of operations, you do the exponents.
Yeah, that's what I had in mind. According to our order of operations, you do exponents before you do multiplication problems. But I did the multiplication first and then the exponent, okay? But I liked what you said there, that only the x is cubed and not the 3. The correct way to do this problem would be to say x is 2 and only the 2 is cubed. So 2 times 2 times 2, that's 8. And then I multiply by the 3, and the correct answer there is only 24. So 216 was way too big, okay? Here's another thing, and we've talked about this before. The same sort of thing comes up when we put minus signs. If we say, like negative 5 cubed or negative 5 quantity cubed, those are not the same thing. This one means that everything in the parentheses is cubed. So this is negative 5 times negative 5 times negative 5. And negative 5 times negative 5 is positive 25. But then when you multiply by this other negative 5, a positive times a negative, you get a negative 125. Okay? Now, in this example, they are the same because this one means 5 times 5 times 5 with only one minus sign out in front. Well, 5 times 5 times 5 is 125, and that one minus sign out in front makes it negative. So they turned out to be the same. But that's because the exponent was odd. If this would have been a 2 instead of a 3, then we would have only had negative 5 squared, which is positive 25, but over here we would have had 5 squared with a minus sign in front, and then that would have been negative 25. So they're not the same. So it's really important to pay attention to what is the base. When I say x to the nth power, n is called the exponent, but x is called the base. And whatever the base is, that's what's raised to the nth power. Here, the base was just 5. Here, the base is negative 5, and it makes a difference. All right. So most people have a good idea if I say x to the 4th of exactly what I'm talking about, okay? That simply means we're going to have 4 factors of x. Factors are things that are multiplied together. So there's what x to the 4th means, 4 factors of x. But what in the world would something like that mean? Can I write down negative 3 factors of x? Or what in the world would something like that mean? Can I write down 0 factors of x? Is that just 0 or what? Well, we've talked before about this idea of pattern recognition. So let's do an example. Suppose we have 3 to the 4th power. Now 3 to the 4th means 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th is 81. Okay? Now underneath that, I'd like to write down 3 cubed. And I just said what 3 cubed was. It was what?
27.
27. Now my question to you is, how do I get from here to here, and how do I get from here to here? When I go from here to here, I just do what? Jackson?
Subtract 1.
Subtract 1 from the exponent. How do you get from 81 to 27? What operation would turn an 81 into a 27? Jackson?
Just divide by 3.
Divide by 3. When I subtract 1 from this exponent, that takes my answer and divides it by 3. Does that make sense? Well, let's do it again. Let's subtract 1 from this exponent, and let's divide this by 3. Is it still true? Okay, good deal. Let's do it again. Let's subtract 1 from this exponent, and let's divide this answer by 3. 3 to the 1st just means 1 factor of 3. But see, here's the thing now. Let's do it one more time. In fact, let's do it 2 or 3 more times. Let's subtract 1 from this exponent. But we have to divide this by 3. And 3 divided by 3 is 1. So that's usually kind of a surprise, that 3 to the 0 means 1. Okay? As a matter of fact, any number to the 0 means 1. If you think about it, what would it look like if I would have started with 5 to the 4th? Every time I would divide by 5. So when I got down to 5 divided by 5, I'd still get 1. So any number to the 0 power is 1. That can save you a lot of work when you're doing complicated problems. If you see something like this, and the problem says simplify that, you don't have to do anything, because anything to the 0 power is 1. Okay? Well, let's learn something else from this example. Let's continue the pattern. I keep subtracting 1 from the exponent. Let's do it again. And I keep dividing by 3. Let's do it again. Negative exponents also make sense. 3 to the negative 1 actually means a fraction. It means 1 over 3. And if I do it again, I would have to take that number and divide it by 3, which is the same as multiplying by 1/3. So I would get 1/9. 3 to the negative 2 is actually 1/9. Now I would like to make that a little bit bigger to make sure you see it. 3 to the negative 2 is 1/9, which is the same thing as 1 over 3 squared. So negative exponents do make sense. When you have a negative exponent, that just means you should push it to the bottom and make it be a positive exponent. So if I said something like, what is 2 to the negative 5th power? Well, you would just say, well, that's 1 over 2 to the positive 5th power. Okay? Just push it to the denominator and it'll become a positive exponent. Now 2 to the 5th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2 is 32. So 2 to the negative 5 power is actually 1/32. Now in this unit, we'll use our calculator a little bit. I can type into my calculator 2 to the negative 5th power, and what it'll do is it'll give me the decimal form of 1/32. Okay? So far, I can summarize what we've learned about exponents in this class with three statements. And the first statement is any number to the 0 power is always 1. Okay? And the second statement is if you have a number to a negative power, just put it to the denominator and it'll become a positive power. Okay? And then there's another one that we didn't mention. What if the exponent with the negative is already in the bottom? Well, then you put it to the top. And it'll look like so. Okay? So if I asked you what is 1 over 5 to the negative 2, I'm just going to take that 5 to the negative 2 and bring it to the numerator, and it becomes 5 to the positive 2, and 5 to the positive 2 is obviously 25. Okay? Again, if you think about what negative exponents mean, they really mean fractions. So wouldn't this be the same thing as 1 divided by 1 over 5 squared? And how do you divide fractions? You multiply by the reciprocal. So this is 1 times 5 squared over 1. And we get 25. So you don't need to remember that, but this you do need to remember. If you have a 0 exponent, the answer is automatically 1. If you have a negative exponent in the numerator, then you put it to the denominator to make the exponent positive. And going the other way, if you have a negative exponent in the denominator, then you put it to the numerator to make the exponent positive. Okay? All right, we're going to spend a lot of time with exponents.